Hello viewers, in today's class we are going to discuss an important differential equation, right? So here we have to solve this differential equation, and the boundary conditions are also given, right? So here we have to solve sin x dy over dx minus y is equal to sin x tan x over 2, and the conditions are x is equal to pi by 2 and y is equal to pi, right? So now here first we will find out the general solution, and then we'll find the particular solution of this differential equation using this boundary condition, right? Okay, so now let us start. Now viewers, here if we analyze this equation, we see that this equation is a linear differential equation of this type, that is dy over dx plus py is equal to q, right? Here p and q are the functions of x, right? So now let us first transform this equation into this form. So for this, what we will do, we'll divide both sides by sin x, right? So dividing throughout by sin x, we have dy over dx, then we have minus y over sin x, and here sin x get cancelled, so we have tan x over 2, right? Now this equation can further be written as dy over dx plus minus 1 over sin x y and tan x over 2, right? And we can further write it as dy over dx plus minus cosec x y is equal to tan x over 2, right? So now we see that this equation is of this type, that is dy over dx plus py is equal to q, right? So this is a linear differential equation of this type, right? And here if we compare, we see that the value of p is minus cosec x and the value of q is tan x over 2, right? Now in order to solve this type of linear differential equations, we have to first find the integrating factor, right? And the integrating factor is denoted by if, and the integrating factor of this type of linear differential equation is given by e raised to integral of p dx, right? And here e is the exponential number, right? So now here we have e raised to p dx, integral of p dx. P is minus cosec x and dx, right? Now from the integrals, we know that the integral of cosec x is given by log of tan x over 2, right? So this is the basic formula for integral of cosec x, right? So now here we have e raised to minus log of tan x over 2, right? Now from the properties of log, we know that we can write it as e raised to log tan x over 2 raised to minus 1, and this can be written as e raised to log 1 over tan x over 2, right? And this can be written as 1 over tan x over 2. This is cot x over 2, right? So here we have used the famous rule, that is e raised to log of p is equal to p, right? So now the integrating factor of this differential equation is cot x over 2, right? Now the solution of this differential equation is given by y multiplied by integrating factor, then we have integral, we have q times integrating factor dx plus c, right? So this is the solution of this type of linear differential equation, right? So now here c is the constant of integration. Now we'll substitute the value of integrating factor and q, right? So now we have y times integrating factor, which is cot x over 2, and here we have integral q. Q is tan x over 2, and the integrating factor is cot x over 2, which can also be written as 1 over tan x over 2, and here we have dx plus c, right? So now we can write here y times cot x over 2, and here tan x by 2 and tan x by 2 get cancelled, and we have integral of dx plus c, and we have y cot x over 2 is equal to x plus c. The integral dx is equal to x, right? So this is the general solution of the given linear differential equation, right? Now we have to make use of this boundary condition, that is x is equal to pi by 2 and y is equal to pi, in order to find out the particular solution, and here to find out the value of this c, where c is the constant of integration, right? So now we'll put x is equal to pi by 2 and y is equal to pi in this general solution. So we have pi, and we have cot pi by 2 over 2, and here we have pi over 2 plus c, and this is pi times cot pi by 4, and here we have pi by 2 plus c, and cot pi by 4 is equal to 1. So we have pi times 1 is equal to pi by 2 plus c, and c is pi minus pi by 2, that is 2 pi minus pi by 2, that is pi by 2, right? So the value of constant of integration, that is c, is equal to pi by 2. So now we'll put c is equal to pi by 2 in this general solution. So therefore we have y cot x over 2 is equal to x plus pi over 2, right? So viewers, this is the particular solution, solution of this differential equation when the boundary conditions are given as x is equal to pi by 2 and y is equal to pi, right? So viewers, this is how we solve this problem.